Morning everybody. Today we are discussing the allotropic form of the carbon. As you know that the allotropy means it is the existence of the different form of the carbon, different form of a material or element. Here we are discussing the allotropy of the carbon. Carbon have the two allotropic forms which are in the crystalline and amorphous. And the crystalline forms are the allotropic forms are the diamond, graphite and fullerene. And the amorphous form are the coal, charcoal, coke, lamp black, etc. So first of all we are moving into the allotrope of carbon, that is the crystalline allotrope of the carbon. We are already discussed that is the graphite and diamond and the fullerene. So the graphite has a layer like structure and the diamond has an sp3 or three-dimensional structure. As you know that the diamond is the hardest non-natural substance which is used as a very good abrasive, and whereas the graphite is a very soft and slippery and hence frequently used for the lubricant. And as you know that the diamond is an insulator, whereas the graphite is a good conductor of the electricity. And the graphite has a layer like structure also. And we are now moving into the diamond structure. As you know that the diamond is an sp3 hybridized compound. sp3 hybridized carbon is existing in the diamond, and it has a three-dimensional like structure and having the bond angle of the 109 degree 28 minute. And the carbon is completed, all the p orbital in the carbon atom is utilized in the hybridization. That's why it does not show any electrical conductivity and it is a perfect electric insulator. And now we are moving into the graphite. You know that the pencil lead is the graphite, and the graphite is an sp2 hybridization and it has a trigonal planar like fashion and it has a layer like structure, and the bond angle of the layer like structure is 142 picometer, and each layer consisting of a hexagonal ring of the carbon atom, and each layer are connected by the van der Waals force of attraction. Here I have shown the layer which is binded by a thread like bonds. These are the van der Waals force. As you know that the van der Waals force is a weak bond of attraction and having the bond length of the 340 picometer. Okay, and here the hybridization is sp2. That means one of the p orbital of the carbon atom does not involved in the hybridization. So this p orbital contain and one electron, and which is used for the the electrical conductivity, or this electron in the p orbital can move anywhere in the graphite structure. That's why the graphite is a electrical, it shows the electrical conductivity. And now the third crystalline allotrope of the carbon is the fullerene. As you know that the fullerene is a football-like structure having the pentagon and hexagonal like structures of the carbon is inserted in the fullerene. And the fullerene was first discovered. Fullerene is the C16 molecule and it is known as Buckminster fullerene. And there are lot of fullerenes consisting of the C60, C70, C76, C78, C80 as C84 is also available. But the spherical fullerene are called the buckyball fullerene. And the Fullerene, as you know that in this structure, as I shown in the figure, it consisting of the 5-membered and 6-membered ring. And as in the case of the graphite, the hybridization is sp2, and the 1p orbital in the Fullerene is not utilized in the hybridization, and the electron which is present in the p orbitals is used for the for creating the aromaticity in the Fullerene. So the Fullerene is discovered in 1985, and it is an accident. The graphite which is irradiated by the laser at more than 10,000 degrees Celsius. The Fullerene can be made by evaporating the graphite rod and appearing an electric arc at about 130 bar. So this is the major discovery of the scientist, which is in 1985. So now we are in 2020, but even then the reproducibility of the Fullerene is very difficult. Okay, thank you.